All right, guys, so today, the nice part about today is it's a pretty short lesson. All right, we're going to talk about something called volume of a composite figure. And the reason why it's a short lesson is because it's one of those lessons that takes a couple of our previous lessons. It just kind of puts them together, okay? So the first thing is the whole idea of volume, okay? So we just talked, right, about volume of prisms. And volume of prisms talks about, remember, how many of these cubic units can fit inside of an object, basically. That's kind of a rough idea of what we talked about. Okay. Then last week, we spoke about composite figures. Last week, we talked about two-dimensional composite figures, like triangles and rectangles, and like one put on the other, right? We had to find out the area of those. Well, today what we're doing is we're going to see composite figures, but we're going to find out the volume, meaning that they're going to be three-dimensional objects. Okay? So you'll see like a triangular prism on top of a rectangular prism. But here's the neat thing. Just like when we were finding out the area of composite figures, so you found the area of both of the different shapes and then added it together, today's exactly the same thing, the same steps. But instead of finding, of course, area, we're finding the volume of each one and adding the volume together to find out, again, how many of these things, right, fit inside of that three-dimensional figure. All right, so that's today's lesson. Let's go ahead and let's take a look on 692. And let's check out problem number 1. Okay, so on problem number 1 on 692, could have a little sketching here of that. Looks kind of like this. Okay, and the dimensions, that side is 13 inches, this side is 6 inches, this side here is 8 inches, and then it shows us the peak of the roof of this. I call it the roof because it looks kind of like a house, right? And that line right there represents 7 inches. Okay. So when we do this lesson, all right, we're going to, like I said, go through basically the exact same steps. So here we go. Just like the other day, step 1, instead of finding the area of the first figure, we're going to find the volume of the first figure. I'll put just volume number 1. You say, well, Mr. Wilkins, what are you talking about? Well, first of all, we have a rectangular prism on bottom, and it looks like a triangular prism on the top of it. Okay? Say, well, which one is the first one? It doesn't matter. Because remember, in the end, we're finding out how many cubes are going to fit in here, how many cubes are going to fit in here, and then we're just going to add them together. Right? 2 plus 3 is the same as 3 plus 2. When you add, it doesn't matter. So in that case, it doesn't matter which one we figure out. Let's start with the easier one, or my opinion is the easier one. That's the rectangular prism on the bottom. So remember, the volume formula for a prism is the area of the base times the height, or times the third dimension. So the other day, I'm looking over your guys' homework that you turned in, and to no surprise, looking over your work, not everyone, but a lot of us, in a lot of my periods, I realized that our grades weren't as good as they should have been. And then I looked at the work, and even though I asked you guys to do this part here and the part that I'm about to do, not many people did. And they skipped that because they figured, you know what, I can do this a lot faster than what Mr. Wilkins showed, and they made errors because of it. So this is your guys' second chance to do the right thing, to learn this the right way, and to eliminate those errors. So here we go. What you're going to see is just basically all the basic steps off of our volume lesson. So here we go. Remember, volume is the area of the base times the height. Now the base is, of course, whatever the end is on that prism. Considering this is a rectangular prism, the base is going to be a rectangle. So the base, it doesn't really matter which one on a rectangular prism. I'm going to go ahead and just choose this one right here. We'll say that's the base. Now, being a rectangle, right, the area of a base or I'm sorry, the area of the base or area of a rectangle is length times width. I'll bring down the h because that's our third dimension. And then what I'm going to do after that is plug in the actual dimensions for our length of our rectangle and our width. So here's, we can call this the length. It's 13. Then the width of this is right here. The width of this rectangle is the same as this right here. It's 8. I'll bring down the h again for our third dimension. Now, 13 times 8, if you want to, you can grab the calculator. 13 times 8 equals 104. So that, remember, is the area of that rectangle. 104 square, what are they? Square inches, okay? But that's not our volume yet, right? Because like we talked about the other day, we need to find out how many layers it goes back, meaning it's the third dimension. In this case, it goes back 6 layers or 6 feet. So I'm going to go ahead, our third dimension is 6. So I take our 104, multiply by 6, and I get 624. Now listen, I'm not going to worry about putting units on because we're not done with the problem. I just need to make sure my final answer has our correct units. Now comes step 2. And that is, we're going to do it all over again, but we're going to find the volume of the second one. So in this case, the volume of the second prism starts off with the same formula. However, at this point, the base on this one is not a rectangle. It's this triangle. Triangular prism is named off of its base, a triangle. So the area of a triangle, remember, is 1/2 base times height. And then I'll bring down this h for the third dimension. So I'm going to go ahead and just like we did before, I'm going to plug in my numbers for my triangle. The base of the triangle is here, which is the top of the rectangle, which means it's 13. The height of our triangle is right here. It's 7. I'll bring down h again. So here's what I'm going to do. 13 times 7. 13 times 7 equals 91. And then remember, it's a triangle, so I have to split it in half. I could do that on a calculator by dividing by 2. And I get 45 and 5/10, 45 and a half. Now, remember, we plug in our third dimension. In this case, how many layers back it goes, right? And it goes back, in this case, it goes back the same as this, 6. So I plug in 6. 45 and 5/10 times 6 equals 273. So ultimately what this means is 624 cubic inches inside the rectangular prism. Inside the triangular prism, there's 273 cubic inches. And now what we do for step 3 is we take those two and we add them together. 624 plus 273. Oh, that's 798. A little faster to do that than use a calculator. Now step 4 isn't it is a real step, but it's just more of a reminder. That is, put your correct units on it. And this, everyone, remember we're in inches, and it's volume, so it's cubic inches that we're measuring this composite figure with. 897 cubic inches. Okay, questions on that? Okay, here's the one I want you guys to try. Flip over to page 694. Take a look at problem number 10. And every part of that diagram, or I should say every part of the question that says find the surface area, ignore. I haven't told you about surface area. What I want you to do is find the volume of that, what happens to be a house. Find the volume of that house that they're showing you. Okay? All right. I'll check in with you guys in a couple of minutes. Go. Okay, anyone need more time? Okay, I'll give you guys about another 30 seconds to a minute there. Again, if you guys have finished, right, go ahead and work ahead. Work on your homework. Okay, 30 seconds. Turn to your neighbor and share your answer. Go.
I did the rectangle first. Base times height times 9 got 90. Multiplied that by 12, got 1080. Then I did triangle. V equals half the base times height. And I did 10 times 5. Did 50. Divided that by 2. 25. 12. 300. Add that together.
Okay, so I'm going to save a little time by not drawing all the little doors and windows, but basically it's pretty much just what we did before. Okay, so here we go. You're going to see me go through all three of these steps up above. Here we go. The very first one is I'm going to go ahead and work on the rectangular prism here, and I'm going to start with the area of a rectangle, which is length times width. Or I guess times h. There, I'll bring down my h. Now the length of this, it doesn't really matter. We could say is 10. If that's the length, then 9 is the width of the rectangle. Bring down my h. 10 times 9, the area of that rectangle is 90. Of course, I now need to multiply it with the third dimension. How many layers it goes back? It's 12. So 90 times 12 equals 1,080. Okay, now comes the triangular prism. So, area of a triangle, we've talked about, is base base times height, times our third dimension. So let's go ahead and plug in here. So the base of the triangle is this one right here, which is the same as that. It's 10. The height of our triangle is right here. It's 5. Bring down our third dimension here. Well, 1/2 of 10 is 5, right? And 5 times 5 is 25. The area of our triangle is 25. I'm going to go ahead and plug in our third dimension. Well, how many layers does it go back? Well, it goes back the same as this. It goes back 12 layers. So 25 times 12 equals 300. So, step 3, I had those two together. We have a 1,080 cubic meters in the rectangular prism, 300 cubic meters in what looks like kind of like the attic. And so when I add them up, 1380, put our units on there, cubic meters. 1,380 cubic meters. Say, well, Mr. Wilkins, wait. Where's 7.1? Ladies and gentlemen, I did warn us about this. That's why you don't grab all the numbers and just multiply things randomly, because that could help you with surface area, which we'll get to eventually. That is worthless on finding the volume of the house. So be very careful. Use the formulas to guide you. Okay? All right, guys. Volume of a composite figure.